Greetings, ladies and gentlemen. My name is Samuel Kožuch, and today I will be guiding you through the advanced training for the Keboola platform. This video will provide a deeper look into using the Keboola platform. We will touch on the best practices on how to use Keboola, and we will expand your knowledge about the whole ecosystem. First, before we get into the tutorial, let's briefly recap what Keboola is. Keboola is a very powerful ETL tool which allows you to load data from hundreds of sources such as databases, SSS, applications, marketing sources, online traffic tools, augmentation services, and much more. The data is then safely stored in Keboola storage and can be analyzed or transformed in R, Python, or Snowflake, a very powerful cloud-based SQL engine. On top of that, a list of third-party machine learning services is available to further extract information from the data. This transformed data can then be loaded back into any database, CRM system, or any other desired BI tool. Keboola itself works as a set of microservices interacting with each other all through the storage component. Storage is a separate layer that may be implemented on various technologies such as Snowflake, Redshift, Azure, etc. And it contains all of the data in the project, including component configurations, tables, and files. Each component is allowed to read the data from storage, write back to it. It all depends on the specification of the component. Before we dive in, let's also go over a terminology that will be used throughout this tutorial and which is a standard terminology used in Keboola. As I already mentioned, we have a plethora of components in Keboola, and each component can have many configurations. In the screenshots you see, we have a QuickBooks extractor that extracts the data from the cloud accounting service QuickBooks. In the screenshot, there are three configurations present for the extractor. One is extracting a journal, another one is downloading data about procurement, and the last one about sales. The configurations in this case would be extracting different data, hence they would have a different configuration, but they're still utilizing the same component. If you've worked with Keboola before, you've definitely came across transformations. In Keboola, transformations are grouped in buckets. In this case, there's a bucket called HubSpot, which contains all of the transformations related to processing and transforming the HubSpot data. Folded in can be one or more transformations, which would then transform the data based on the defined queries. In this case, we have 4 transformations present in the bucket. They all work with the HubSpot data, and it's a very good practice to have them folded together in one bucket. The order of execution in a bucket can be set by changing the phase or setting a dependency for a transformation. For each transformation, a phase defines when the transformation is executed within the transformation bucket. For greater control within a single phase of transforming, you can add a required transformation, which will first execute the required transformation and afterwards it will execute the dependent transformation. This setting is only available for transformations present within the same phase, but more on this will be covered later. For added clarity, a concept of multi-project architecture can be used. The concept wraps around the idea of splitting what would normally be one very big and messy project into multiple smaller projects that allow greater control, easier maintenance, and better tidiness within the project itself. The projects in multi-project architecture concept can be split based on departments or their purpose, and then stage the data pipeline to share the data between all of the projects. As a basic configuration, for example, there might be a level 1 and level 2 project present in the architecture. Level 1's purpose would be a minor cleanup of the data pipeline or forming very simple single tables that would be used later on in level 2. And then the purpose of level 2 would be to execute the final data pipeline, merge the single tables from level 1 together, and create one final table used in reporting. A very simple multi-project architect may have the following form. In this case, there are 4 levels of projects. We start with level 0, which is a data acquisition or basic transformation project. These projects extract data from relevant sources for each department. Afterwards, we have the L1 projects or level 1 projects that could create single tables, very simple joins. In this example, there is a table with sales orders and ordered items being linked together. In the following project, L2, this data can be combined with marketing to provide more sensible insights. And then we have level 3, which offers a full data catalog of objects, which can be pushed to a reporting tool and utilized by any department's analytics team. So I hope that all of the terminology used throughout the video is clear now. In this next section, I will be talking about the best practices for transformations and mainly SQL transformations, which you should follow in order to get the best results, the fastest result, and the most consistent results you want. So let me first start with a brief overview of what the transformation is. Transformation in layman's terms is a script which can be used to manipulate the data. In Keboola, it operates in a completely separate environment. This environment is provisioned for each transformation run separately, and it is independent of the storage backend. So it is quite a common sight to have a Snowflake as a storage backend and to use Python transformations. All of the transformations offer versioning, the complete history, and the fast rollback. So in case there is any change that did not work, you can very quickly find this change and roll back to a previous version of the transformation. In addition to transformations, we offer sandboxes. So these sandboxes are in the same backends as the transformation. So it can be either SQL, R, Python, or OpenRefine. These sandboxes can be used to explore the data, to experiment, to just quickly examine the data, and they operate on copy of the data. So you can experiment all you want. The active data, the live data is not affected by any change, by any bad experiment. So you know it's safe. These sandboxes are limited to one sandbox per backend, per user, per project. And of course they come with some limits. So they have a soft limit of disk space of 10 gigabytes. The memory is limited to 8 gigabytes. The runtime is 6 hours. And it is important to mention that all of these limits are soft and can be adjusted per request, per project. So let me start with some best practices for transformations. First, we have to avoid the alter session statements. The reasoning behind this is that some of the transformations execute in a single workspace. This may lead to an unexpectedly unpredictable behavior within this Snowflake workspace. Also, the transformations may be executed in an unpredictable order. So sometimes you may have the alter session executed before something else, sometimes not. Moreover, the loading and unloading sessions are separate from the transformation sandbox sessions, and it may lead to a format change. I'll be talking about this on the next slide. It is better to use the explicit statements instead of the global session parameter changes. This leads to better readability, better transparency. So the first example, I will be talking about the timestamp output format. We see this quite often that people want to change the format of the timestamp. So let's say instead they prefer this year, month, date in 24-hour format. What they usually do is they try to use the alter session statement and alter the timestamp output format parameter. However, this will only work in the transformation, and once the table is inputted into the storage has its own session with its own parameters, and this timestamp format will be changed back. So instead, what should be done is, for example, use this variable as a def timestamp format and cast the timestamp to a character, which will give you your desired format. Another one we have is the time zone. So people try to change the time zone using the alter session statement. However, the same case as before, the storage session is separate from the transformation, and on load to storage, this will be changed back and may lead to wrong results in the transformation or in the table itself. So instead, you should use the convert time zone function, change the timestamp into your desired format or time zone. Another one is to avoid using the select star statements. The select star statements are very fast, but they are not very transparent. For example, what happens if you remove a column or if a column is added? In select star statements, these columns are excluded automatically, so it does not give you that control of the data flow. Instead, it is better to be explicit about it, to list the columns. Although this will be more lines of code, you are trading off for clarity because it gives you a clearer picture of what columns are used in the transformation, and you can read this directly from the code. If a new column is added, this method is robust to it. If a column is removed, you will know about it because it will result in an error. The next thing I will be talking about, I already touched on this, is transformation phases and dependencies. So phases give you a control of how the transformation should be executed, what should be their execution order. All of the transformations within a single phase are executed in a separate workspace, and phases are recommended to be used only when you absolutely need to export the product or the table into the storage before another transformation takes over. This is, for example, when you want to prepare the data in a SQL transformation and then use a Python script to transform the data further. So you would have a SQL transformation in phase 1, and in phase 2 you would have a Python transformation which would work with the output table from phase 1. In addition to phases, we have dependencies. Dependencies give you a control of transformation execution within a single phase. This also gives you performance advantages, as input and output mapping is only done once, and all of the objects created within the phase are visible from all transformations involved. On this diagram, I will explain to you how the phasing and dependencies work. So on the right hand side, we have the Keboola storage, and on the left hand side, we have these two valves, which is basically our phase 1 execution and our phase 2 execution. So first, we'll start with the phase 1. Before the phase 1 starts executing, the input mapping is done, so all of the required tables for all of the transformations in phase 1 are loaded into a separate workspace. After the input mapping is done, we can see that we have 3 transformations there, and we have transformation 2 being dependent on transformation 1. So the way this is executed is that transformation 1 is executed first. Once it finishes successfully, transformation 2 is executed, and once this transformation is executed successfully, all of the other transformations are executed in a random order. Once all of the transformations in this phase are finished, the output mapping is performed, so all of the mapped table from the phase are taken and loaded back into storage. After the output mapping is done, the workspace is dropped. For phase 2, another workspace is created, and again all of the tables are loaded into the phase, and then since we do not have dependencies in this one, the transformations are randomly executed again. Once they are finished, the output mapping is done and the workspace is dropped. The best practice for phases and dependencies is to use mainly dependencies in order to ensure that all of the necessary transformations are performed when you trigger a single transformation manually. This also gives you an ability to execute parallelization, since the parallel input and output loads are done with dependencies, and objects can be shared across transformations, allowing better code segmentation. Keboola also offers a integration with SQL Dev Service. SQL Dev Service gives you an ability to explore the relationships between objects, between tables, columns, queries. So it analyzes the queries you are using and creates this very nice relationship graph where you can see all of the objects related to each other, etc., etc. Another best practice we have is to avoid complex nested queries. We have many customers coming from legacy systems such as Oracle, where they are encouraged to use the complex nested queries in order to save some memory. This is not the case with Snowflake. Instead, we recommend to split nested queries into as many atomic pieces as possible. This gives you a better code readability and easier maintenance, and you have a decreased chance that the query will reach the execution time limit imposed by the data warehouse, as using as simple queries as possible lowers the execution time. Moreover, those temporary tables can be reused by other queries in the same transformations or within the same phase. So for example, the code on the left, you can see we have 2 nested subqueries. Instead, what we can do, we can create these pref values and lead values tables, which are used in with statements. We can create them before using the create table statements, as you see on the right. So first we create the previous values, then we create the lead values, and then we create our output table by simply joining the previous values and lead values. This will basically simplify the whole execution diagram, meaning meaning the whole execution should be much faster. Another recommended way is to use the mapping tables instead of the very complicated case when queries. Often we see that some customers use multiple nested case when queries, which slows down their execution a lot. What can be done about this instead is to use the mapping tables and simply join the mapping table on the output table, and you get this functionality as well. Plus you get a faster execution. In this section, I will be talking about defining the input and output mapping. Defining input and output mapping is very important because it gives you control over what data you process, it gives you control about how much data you consume, etc. With input and output mapping, you can declare what data is taken from the storage and loaded into the secure workspace for transformations, and you can also define what data is taken out of that workspace before the workspace is deleted. Keboola offers several techniques for control over the input and output mapping, which can enhance the performance of the stage. Some of the features are what table import mode you want to use. You can impose some filters or do some data conversions or some data cleaning. So let me first start with the copy table mode, which is a default mode for loading tables into the workspace. It gives you a great variety of filters. One of those is, for example, the column filter, where you can select the subset of columns used in the transformation. This reduces the load time and the volume transferred. If you have a table of 200 columns and you know you will only need 5, you can define these 5 columns in a column filter and only these 5 will be loaded into the workspace. Next we have an incremental load, which is called the changed in last. It allows you to specify the date interval of the data, and only the data that was changed in this interval will be loaded into the workspace. The filter works with the metadata column timestamp, which marks the timestamp of row being imported into the storage. Another filter is a data filter, where you can specify a very simple condition and the data will be excluded or included within this condition and loaded into the workspace. And another filter we have is it's not a filter per se, but it's a data type conversion, so you can convert any column into a desired format, though we do not recommend this as this feature reduces the clarity of the code as you are performing some data type conversion outside of the code. Another import mode is clone table mode, which leverages the zero copy clone functionality of the Snowflake data warehouse. With this load, there are no data types, no filters, but it is very fast. For example, a 200 GB table can be loaded with clone mapping within 20-second range, while it would take something around 1 or 2 minutes for a copy. It is extremely useful for extremely large tables as this speeds up the transformations. And as I was saying, there are no filters or setup for the clone table mode. You can only select the alias that will be used with this table. The credits consumed with the clone table mode do not change. They are exactly the same as you would do a copy table mode with no filters. It only offers the performance advantage. Keboola works with a variety of loads. One of those is incremental versus full load. So the incremental data flow processes only the data changed since the last successful run or within some period. The full data flow or the full data processing processes all of the data every day. Keboola can be used for full loads, also can be used for incremental load with a primary key, which is the type 1 slowly changing dimension, or the incremental load without the primary key, which is the time 2 slowly changing dimension. Or you can use custom-made components to have the type 3 slowly changing dimension, for example, to create a table snapshot and know when this is valid from what date to what date. For writers only at this point, we also have the functionality of automatic and manual incremental load. So let me start with the automatic incremental load first. The automatic incremental load only appends the data since the last successful run. So it keeps a timestamp, that metadata column of the maximum timestamp of the last row outputted. And once new data arrives, only the data after this timestamp are loaded in. The manual incremental load allows you to append the selected data within the specified date range. So let's say within the past 2 days, if there's a primary key set, the updates will be applied to those rows with matching primary key values. In case you're unfamiliar with orchestrations, it allows you to automate some tasks. So for example, you can define the tasks you want to be executed, you can define the time you want to be executed at, and basically every day or every hour, every minute, the execution will be triggered. Some best practices for orchestrations we have is to set up group notifications or notifications to a group chat. In case there is any failure or a warning, this gives you full transparency of the orchestration. Plus, given that it's in the group chat, a larger amount of people is covered, and this in turn provides a faster reaction time. Besides the standard time-based orchestrations, we also provide event-triggered orchestrations. So for event-triggered orchestrations, you define a set of tables that is watched basically all the time. Once there is a change in a table and all of the tables are changed, the orchestration is triggered. Moreover, you can specify a cooldown period, and in the cooldown period, the orchestration is not triggered. So this is a way for you to limit the orchestration run so it doesn't run almost all the time. And if you're asking what is a change, is basically any table import, even if it does not contain any new data. Even if it's incremental load with all the same rows, the import metadata's timestamp will still be overwritten and the orchestration will be triggered. So let's now talk about storage. Storage is the central KBC component. It is managing everything related to storing data, accessing it, contains information about tables, files, component configuration, etc. It is implemented on top of various database engines or storage services. Currently it's Snowflake and S3, but there's a possibility of Redshift and Azure as well. For table storage, this one stores all the table data created by the components or table imports. It is currently based on Snowflake backend, but as I was saying, it is very easy to change it and use a different backend. Snowflake was chosen because it has some great functionality such as backups, restorations, time travel function, etc. It does not have any limitation to data types. It supports semi-structured data formats such as JSON and XML. All of the tables in storage are stored or organized in buckets. You can think of buckets as folders, and these buckets can be shared across projects or organizations. Storage can be accessed via Storage API. You can interact with other components via this API. Then we have file storage, which stores basically any data. It can be a CSV file, an arbitrary file such as R modules or Python modules, some scripts. And every tabular load is first loaded into the stored files, and then it is processed and pushed as a table. One great thing about storage is that you are in complete control of everything that is happening. Any interaction with storage is logged. So somebody views a table or fetches a preview, changes a primary key, etc. Everything is in the events of the table or in storage in general. So you can very easily see who made some changes, when was something done that broke some other transformation, etc. Every payload result of a transformation or component is stored in files before push to storage, I was saying already, and every storage job is linked to the actual component job via run ID, so you can very easily track what job was responsible for certain storage job. We also offer data lineage preview with the functionality of graph. So graph has two modes, either backwards or forwards. With backwards, you can look at all the transformations and data inputs that are happening before a table is created. In this case, we have table mail in bucket iTunes, and we can see that it is created in transformation iTunes price changes using for tables, iOS snapshot, MS snapshot, etc. Then we have the forwards mode, which is exact opposite to the backwards mode. So that one previews all the transformations and tables which are happening after this table is created. One great thing about storage are descriptions. So we support column and table descriptions, and you can write these descriptions in Markdown. It is a very good practice to use these descriptions just to provide a very simple context of what is contained in the column, what is contained in the table itself, and these basically can be applied to all other components. It is very easy to debug and orient in the project that way. For tables, you can set data types. In storage though, everything is treated as a string because this gives you more flexibility on loading data, but you can set up a metadata column which will have the data type defined for that column. Data types are also transferred from the database extractors. So in case you're extracting tables from database, the data types that are set in the database will be transferred to the metadata layer of the storage for that table. Generally, data types are needed on the output though. You can define data types on columns in the output stage, and those will be transferred to any new and write configuration. There's no need to define them in the transformations except for some particular cases, for example, some date operations. Snowflake has great inferring function, so it knows automatically to convert, for example, string to number when you're using the sum function. And for a best practice, as I was mentioning a couple slides earlier, it is recommended to cast all the data types explicitly in the code, as this gives you better clarity of what is going on with the table. All of the data types which are inherited by the extracted tables can be changed by the user in the UI. It is very easy to change them in the table settings, and the source data will exist for Lineage and audit sake, but the override data will take precedence. Metadata for data types, you can define for each column what type it is, but it's still stored in storage as a varchar. The data types are only for metadata purposes, and afterwards when you load the table in the transformations, all of those columns will have casting function defined for those that you need. If the column contains data type errors, your transformations will error out on the input phase. Some table operations that can be done is in storage. You can delete the table or truncate it. You should use this function with caution, as it is a very destructive way of deleting all the data. Usually we use this only when you want to completely replace the table. You can also add or remove a primary key, but you need to be very careful because it may break a data lineage. For example, dependent transformations that are outputting to this table would not have a primary key set and would fail. You can also create a new column or delete a column. Again, this may break backward or forward dependencies, as you will be missing or you will have an extra column when dealing with data in transformations. And as I was saying, you can change the column data type. You can also in storage create aliases. You can think of aliases as a copy of the table that is the exact mirror copy all the time. So let's say I create an alias of some table, then I change my original table, and this change will automatically be reflected in the alias as well. You can share aliases into shared buckets, and then these can be aliased further or shared further, etc. The metadata layer, we collect a lot of data, or metadata are generated. Most basic ones are catalogs on informations of data sets such as schema structure, business descriptions, business context, taxonomy locations, ownerships. We collect data on operational metadata such as jobs, execution information, timestamps, etc. Lineage information metadata, which is the connection between component, jobs, data sets, storage of jobs, etc. And some data profiling statistics to reveal the column level and set level characteristics of the data set. Metadata collection and generation is done and can be accessed via storage API. It is collected from the system information, for example, the operational metadata, and the generated data is, for example, data profiling and data lineage. Now, how not to use the Keboola storage? The Snowflake DB, that is the underlying database for Keboola storage, is an analytical database and is not very suitable for the following cases. This includes transactional workloads, key value access with high request rate, blob or document storage, or over normalized data. Moreover, you cannot access the underlying storage DB in Keboola. It is all because of the metadata layer that is used on top of the DB. So we've already established that Keboola is a great platform for collaboration and gives you great tools to create fearlessly, to experiment with data, to perform some exploratory data analysis, etc. One of the features we offer are sandboxes. I already talked about them. Sandboxes are a very safe environment for you to explore, analyze, and experiment on copies of the selected data. The important thing here is that everything is done on a copy of the data, not on the actual data. This prevents the actual data to be corrupt or modified in any way and gives you a space for experimentation. Each user has a unique sandbox per project, per backend, and we use Jupyter Notebooks for Python transformations, RStudio for R transformations, SnowSQL client for Snowflake transformations. All of these are hosted online and can be connected to remotely. If you create the sandbox from transformation, the code that is already in the transformation will be copied over to the sandbox, but you might want to, for example, define your own template, which will also be loaded altogether with the code. For this, you can create a template. For example, for a Jupyter notebook, you would create a Jupyter notebook, save it in a storage with a predefined tag. In this case, it's underscore Python underscore sandbox underscore template underscore. And if you trigger a sandbox from a transformation, the template will be appended after the template code. You can do the same for our transformations. The tag is kind of different, but you can also define personalized templates for each user. So in this case, you would use a tag of the email address, define it in the storage. Once the user triggers the sandbox from the transformation, the template will be loaded only for him. With Keboola, we also have markdown descriptions for all components and storage pieces. This is a very important tool for all the teamwork, as it enables you to describe what is going on in your transformation, what is the definition of a column or a table, etc. And it allows anybody to quickly jump in and fix whatever issues there are without lengthy getting to know what the transformation does. The markdown is great because it allows you to format the text, gives you headers, you can use bullet points, you can use bold, italic, etc. For storage, we recommend to define the data structures, types, foreign keys, some personal data columns, temporary tables, etc. For transformations, it is, in case you are using some custom functions, it would be great to include those in the description of the transformation. You can also define or describe inputs, outputs, some to-do section, or some known issues or future known issues. The logic of the transformation should also be included, or how you got from point A to point B. So this is, for example, if we were using plain text, this is what the description would look like. As you can see, it is not as pleasing. It is very hard to navigate. So here is why we're using Markdown. So once you save this, you get a beautiful header, you get italic, you get the code format. So it's very easy to navigate, to jump in, to know what is going on with the component. For each component, we offer versioning. Whenever there's a change made for a certain component, either transformation, some extractor or writer, a new version of the whole configuration is created, and you can see it in the version control as well. The version control is available in the UI and the API. You can very easily restore to a specified version in case something goes wrong, or we also offer fork function to very quickly copy existing configuration to a new one. Some versioning improvements: in case you are fixing something, you can save the transformations with a description. You can visualize this as a kind of a git commit message, so you describe what changes were made, why they were made, etc. As I was saying, you can use fork feature to create a copy of the configuration or a version of the configuration to avoid manual labor such as copy paste and then inputting the tables, outputting the tables, etc. This one is a way easier tool to do this. In Keboola, we log everything. We even log when somebody previews the table or views the sample of the file. We log when there is a configuration change, a new parameter is added or changed. We log all the storage events, so you can see when something was imported, exported, etc. When somebody added a primary key or truncated the table. So there is really not risk of losing the data without knowing why or who did it. Every storage job also contains the detail with all the information about the execution, such as run ID, links to the table that is being affected, the duration, transfer size, number of rows imported, some warnings, or whether the load was incremental or not. And we also offer two great features: data retention and snapshots. With data retention or time travel restore, you can restore the table up to 7 days to any timestamp to your choosing. For snapshots, you can either manually or via API create an ad hoc snapshot for future use or before you make any change, so you know you have this copy of the table ready. And for all the components, we also offer component trash. So whenever you delete a configuration, it will automatically go into the component trash. So if it is, for example, deleted by mistake, you can very easily restore it. As I was saying, you can very easily connect remotely to our hosted sandboxes. This is mainly the case for the Snowflake sandbox. So whenever you create a sandbox, you are given credentials such as host, port, user, and password. And you can very easily use, for example, DataGrip or dbeaver to connect to the database. One thing you might need to do is download the driver, which you can download from the SnowSQL client. So as the last piece of this presentation, I will talk about components and integration of the Keboola platform with other services. So components, we know 4 basic types of components. They are extractor, application, writer, and a processor. The first 3 ones are the most known and used. Fourth one is not as much known, and I will cover it in more detail later. So an extractor allows customers to get the data from news sources and load them into the storage. It only processes the input tables from the external sources. Application, it may enrich the data, it may be some machine learning application that provides some new insights into the data. Usually it processes some input tables and generates some result tables as well. Then we have a writer which pushes the data into the new system. It may be a BI tool, a database, basically takes the table from the storage and outputs it elsewhere. And a processor, which is a component that adjusts inputs or outputs of other components. It cannot be run separately, it always has to be run in symbiosis with other components. It is a very powerful tool on how to alter some inputs and outputs without rewriting the code over and over again. All of the components are run using a Docker runner, and the list of available components can be found on components.keboola.com. We have a very special extractor as well, called generic extractor. It is a very versatile tool that allows you to connect to basically any REST API. You can configure a new extractor with documentation within an hour, so you have the data ready with a completely new extractor. The generic extractor serves as a standalone application. It supports iterations, functions, incremental load. So it's really a tool for all REST API. Then we recognize different extractor types, such as database extractors, for example, for SQL databases and NoSQL databases. Then communication, social network, marketing and sales extractors, and some other augmentation services or blob extractors, etc. The great thing about Keboola is that you can very easily extend the list of any components by writing a custom component. It is very easy to write, to maintain. All you need to do is set up a continuous integration, code it, and you register a component, and that's basically it. All of this can be found in docs or in a different video that is covering the whole process of deploying the application and writing a very simple component. As I was saying, I will touch on processors a bit into more detail. Processors are a very special type of component, and as I was saying, they have to be run together with other components, with other extractors, writers, or applications, and they usually perform a very small action on the data before load into the component or into the storage. Processors may be used together with all the components. They can be either configured via UI if the component supports it, and if there is no UI piece for the processors, you can very easily configure it via an API call. An example of the extractor that uses components heavily is an X-Tree extractor. It basically, on the back end, it always uses those extractors to create manifests, alter the CSV files to get them into the storage, etc. As a use case, for example, you have the S3 report that contains 10 lines of data before the actual data begins. Those usually might be some information about the system. This CSV file would be very hard to load into the storage and would be considered invalid. Instead, you can use the skip lines processor that will skip the first X rows, in this case 10 lines, and will convert the CSV into a valid form. For integrations, you can use KBC as a data handling backbone for your product. So you can either use it just to exchange the data between the API, etc., or you can use it as data handling backbone. You can wrap your application around KBC for customers. You can control the whole data processing pipeline within KBC from the outside, and you can control any component of the KBC programmatically. That is it for me from today. If you have any other questions, please don't hesitate to ask your Keboola representative or Keboola contact person, which should be able to direct you further or help you with your inquiry. Thanks again. Have a good day.